We will discuss Java Servlet architecture. We'll explain the important terms related to Java Servlets. We'll explain the service lifecycle. We'll describe Servlet request, response, config, and context, and we'll list the steps to configure and deploy a servlet. We will also look into servlet collaboration. Let's look at an introduction to servlets. We will go through static and dynamic response, client-server architecture with Java Servlet, web container, client-server architecture with web container. We have learned that web server generates two types of responses, static and dynamic. However, a web server can generate static responses in the form of HTML. To generate dynamic response, a programming language that performs dynamic operations is needed. Servlet is a Java program that can perform dynamic operations and send it to web server. The web server can then send the response to the web client. Every time you type google.com in your browsers, for example, you're directed to the Google homepage. This is called a static page, as the web server displays the same HTML page every time the client requests. When users log into their Facebook account, different pages will be generated for different users. These are not static pages that are served and saved on the server side. They are dynamically generated based on the user ID. So you would hence see pages that are relevant to your login, and this requires multiple responses from the server called dynamic response, and hence we need servlets, which is programming capability on the server side to generate such dynamic content. Here we have a user connected via a browser sending an HTTP request to the web server. On the server we have a web container which has a servlet inside, which probably would want to talk to a database, pull data, do some processing, and generate an HTML file as an output. That HTML file is sent via an HTTP response to the client browser. Web server is a program that sends HTTP response, and servlet is a Java program that deals with classes and objects. How is the response generated in the HTTP format? Of course, it is the web server at work which purely works on the HTTP protocol that does that. So this is done using the web container which is there on the web server. Let's understand what is a web container. A web container is built on top of Java Enterprise Edition platform, and it implements the Servlet API and the services required to process HTTP and other TCP/IP requests. Java servlets are components that must exist in a web container. Web container activates the servlet that matches the requested URL by calling the service method on an instance of servlet class. Activation of the service method for a given HTTP request is then handled in a separate thread within the web container protocol. Here we see the client-server architecture with web container. The life cycle of a servlet is controlled by the web container in which the servlet has been deployed. Here we see the client browser sending an HTTP request to the web server. The web server forwards the HTTP request to the web container. The web container further forwards the request to the servlet in the form of a request object. The servlet generates a response object which it sends back to the outer enclosing web container. The web container converts that into an equivalent HTTP response and sends it to the web server. The web server sends that HTML content via an HTTP response back to the client browser. Let's look at Servlet API interfaces and methods. The Servlet API contains a number of classes and interfaces that describe the contracts between a servlet class and the runtime environment provided for an instance by a confirming servlet container. Servlet API provides the following two packages that contain its classes and interfaces. We have the Servlet javax.servlet package. These are classes and interfaces that define contracts between a servlet and the runtime environment provided for an instance of such a class by a confirming servlet container. Then we have javax.servlet.http. These are classes and interfaces which define contracts between a servlet class running under the HTTP protocol, and the runtime environment provided for an instance of such a class by a confirming servlet container. This largely is the ecosystem in terms of the set of functions, APIs, interfaces and classes available as part of the Servlet API. So first we have Java x.servlet.filter config, which passes information to a filter during initialization. We have Java x.servlet.request dispatcher. This sends request and response objects to any source such as a servlet, HTML file or JSP file on the server. Moving to Java x.servlet.servlet, which defines methods that all servlets must implement. Servlet.servletConfig is a servlet configuration object used by a servlet container to pass information to a servlet during initialization. Servlet.servletContext defines a set of methods that a servlet uses to communicate with its servlet container, for example to get the MIME type of a file, dispatch requests or write to a log file. The servlet context attribute listener. This is an implementation of the interface which receives notifications of changes to the attribute list on the service context of a web application. Similarly, we have servlet context listener, which receives notifications about changes to the servlet context of the web application. Servlet request, which defines an object to provide client request information to a servlet. Servlet request attribute listener, which can be implemented by the developer interested in being notified of request attribute changes. Servlet request listener, which can be implemented by the developer interested in being notified of requests coming in and out of scope in a web component. And servlet response, which defines an object to assist a servlet in sending a response to the client. So all servlets must implement the servlet interface that defines lifecycle methods. The servlet can also be created by extending generic servlet abstract class that implements all methods of the servlet interface except the service method. Another way of creating a servlet is to extend HttpServlet abstract class, which extends generic servlet abstract class. And then you can create your user-defined servlet. The servlet interface has 5 methods as part of it: init, service, destroy, getServletInfo, and getServletConfig. The init method is called by the servlet container to indicate to a servlet that it is being placed into service. It is declared as void init and it takes a servlet config object. The service method is called by the servlet container to allow the servlet to respond to a request, so it takes a response and a request object. The destroy indicates that the servlet is being taken out of service and it has to be destroyed. ServletInfo returns information about the servlet, and ServletConfig is an object that contains initialization and startup parameters for the servlet. The generic servlet abstract class implements servlet interface. It defines servlet generic and is independent of protocols. It doesn't give implementation for service methods of servlet interface. If your servlet extends generic class, implementing service method is necessary. So here we see the abstract class generic servlet, which implements servlet. The getInit parameter, which returns a string containing the value of the initialization parameter, or returns null if the parameter does not exist. GetInit parameter names. This returns the names of the servlet initialization parameters as an enumeration of string objects, or returns an empty enumeration if the servlet has no initialization parameters. Servlet context returns a reference to the servlet context in which the servlet is running. GetServlet name returns the name of this servlet instance. Void init, a convenient method which can be overridden so that there is no need to call super.init. Similarly, we have the init, the log, which is a servlet log method. You can also write an explanatory message to the stack trace using log, and a service method which allows the servlet to respond to a request. The HttpServlet abstract class is an abstract class to be subclassed to create the HTTP servlet suitable for a website. Following is the list of methods. We have a doGet method used if the servlet supports GET requests, a doPost method which will execute when you provide a post request to the servlet, similarly a put and a delete based on the HTTP verbs, initialization and destruction, and getServletInfo which provides information about the servlet itself.